Alright, in this video I'm going to walk you through some angle styles, different types of angles. It started out, I was going to do some right left, horizontal angle right and horizontal angle left for down and out shots if you're not using coordinate system. And then I got to realizing there's a lot about angles that maybe some people don't know. And so I'm going to just go through basically what the different types of angle measurement formats would be. So this is just a random line, 41.9864 degrees. So for every 10,000ths, right, if you're going up 4 decimal places, I think the arc seconds it's less than 1 arc second. And 1 arc second is about a 1/16 of an inch at 1,000 feet. So it's very accurate. I believe you'll be in the air in somewhere around within a 5-foot area if you were using GPS coordinates and you went down to the 4 decimal places. So it's pretty accurate. I'm just going from memory there, but so this same thing here. If you were doing degrees, minutes, and seconds, 1 arc seconds is 1,000th of a foot, or about a 1/16 of an inch at 1,000 feet. So that's very accurate also. And if you're going GPS coordinates, I think 0.10 is like a meter. So 100th of an arc second is within a meter if you're doing GPS coordinates. And that changes as you get farther away from the equator. But let's see. So this one here is radians. If you don't know what radians are, I'll explain just real quick in a second. And then gons, I think that's a European thing. And then instead of 90, 36, instead of 360 degrees in this circle like this, this is mathematical. Starts at 0, goes to 90, 180, 270. So it's going counterclockwise. Gons are in coordinates also like this, starting at 0, and then going clockwise. And it's geographical, I think you want to call it. So the azimuth is 0. North, bearing north is 0, and clockwise. So let's look at this here real quick. So azimuth, 30 degrees, horizontal angle right. And if you have a digital, you usually has a switch in there. You can say if you're in angle mode, you can go horizontal angle left. And that just makes it simpler when you have something like this. Let's say you're doing it down and out for this point here, and your calculation is 41 degrees, 30 minutes, 43 seconds. It's a little more difficult to subtract that from 360. So if you did, you would get a clockwise angle of 318, 29, and 17 seconds, right? So if you could just switch it to, let's say that's your calculation, you would just hit horizontal angle left, and you could just turn that angle and then measure your distance. And then let's go to, I believe I kind of skipped over this one real quick. So bearing, so this is azimuth. This doesn't really belong there. Let's get rid of that. Azimuth is just clockwise, 30, 60, 90 to 100, all the way in a clockwise direction. So if you were flying in a plane or you're in a boat, then they're going to give you a bearing. It's going to be off of true north. Unless maybe plane is magnetic north. I think bearing in the sea. I think I can't remember, but it would just say bearing off of true north or bearing off of magnetic north. I think when you're flying, it's just assumed it's magnetic north. It's been a long time since I've been in a cockpit. However, it's going to be bearing, and it's going to be from 0 clockwise, and they'll tell you it wouldn't be 0. It wouldn't be 30 degrees. They tell you 030 degrees. Everything's always going to have that hundredths. Like 050 would be 50 degrees, right? And then 270. So it's always going to have 3 numbers in a bearing. Let's see. If you don't know how to do this, let's say I'm going to just do one real quick. Draw. Sketch. So 360 degrees is 359. Degrees, because you have to use one of these to subtract, and then instead of 60 degrees it's 59 minutes. and then 60 seconds. So if you add 60 seconds plus 59 minutes and 359 degrees, it's 360 degrees. Then you would just subtract the 41 degrees, 30, and 43. So now you're not going into negative carryovers, just like regular math. All right, so then you go 37, and then that has to get carried over, so that's a 5 actually, so it's 1. That's seconds. And then 9 and 2, that's minutes. And then there you go, nothing got carried over from that, so that's straight 8, and that's 1. And then that's nothing taken off of that one either. That's 3. So you end up with 318 degrees, 29 minutes, and 17 seconds. And that's measuring from here going around in a clockwise direction. Then you have quadrant bearings, which is used in surveying. It's usually going to be degrees, minutes, and seconds. And then right here, there's the accuracy is, let's see, if I went out here, you'd see it probably be in degrees, minutes, and seconds. Nope. I don't know why that is. Oh, because it's bearing, Control Z. Anyways, you would have something like this, and it's going to be off the closest one. Anything on this northern area of this line is going to be north, and then if it's to the right, it's northeast. To the west is northwest, and same thing here, southwest and southeast. And it's just measured off of there. That's I think it's called meets and bounds would be if you went this far to point number 1 or a log or a rock or something, right? That'd be meets and bounds. True bearing, I think that we already kind of went over that. If you're going, it's clockwise from the north, it'd be either true bearing or compass bearing. I think that's what I've missed before. And then 30. And if you notice something like this, on all these angles, 030 and 210, they both add up to 3. If you add the 2 and the 1, it's 3. And then the same thing here. If you went down, that's a H, J, C, 135. Right, and then V, 5. So if you add 1, 3, and 5, it ends up being 9. And then this, I think it's 135, 45, 15, 315. So let's just do that. Draw, dimension, angle, and then put it back in the right. So that's 315 degrees, right? So if 3, 4, 9, you add that up to 9, that also will add up to 9. So if you're running, let's say you're runway 21, right? Then you would know automatically that the opposite direction. So when your wind changes, it's the same runway, it's just different headings, right? So if it's runway 21 and you're going to change it around, it would be runway 3. That's one of this is the little interesting thing that happens with this. That wouldn't happen with your GONs, I don't believe. And then there's 1 radian. So dimension, arc, angle, and then if you went to radians, that's 1 radian there. Close. Right here. And I think that's exactly 1 radian because, yeah. Don't truncate zeros. Close. That is 1 radian. And then the way you would calculate that is draw line. V, draw line. J, away, enter. And then you go, to get that number right there, you go 180 divided by 3.14159. That's 3.14 or 3.16, 3.1416. I mean, and that's just taken out to the extra decimal, so you don't really end up with any error. And then you just go off of that line, and that'll give you that distance, that 52.29 or whatever that number is. I forget. Let's actually see what that is. Draw dimension, arc, text, format, precision. I don't think I'm doing something wrong. Alt-M-A. And then go text. Let's just go degrees, decimal degrees to fourth death place, right? And then that's what 1 radian is, that many degrees. 2958, yeah. All right, so then there's that. And then I think that's pretty much for what the angles are. And like I said, it all started out just because you could do it down and up. But since there was a horizontal angle right and left, I realized there's a lot of other stuff going on with the angles. So your simple down and out. Now I'll do the down and out. Let's say delete. That was showing the same way, right? Subtracting. If you didn't have the horizontal angle left, that's how it started. Because the old total lights, they're just a glass plate, and there's no horizontal angle right in there. You actually have to do the math each time. And then so your down and out here would be overall is 99.94. So tools, calculator. You gotta say arctangent, ATAN, and then it's 117.14 divided by 99.94. Close parenthesis, and I'll just copy that. Control C, hit that, and that'll give you the angle in degrees, in decimal degrees, right? Control V equals. I'm gonna just do one. Control C. It's 49, so 49 degrees. 0.5 is roughly there, so that looks right. Control close, and then let me zoom in a little bit. So that gives you the angle in degrees, minutes, and seconds. 49.503. If you don't know, if you want to convert that to degrees, minutes, and seconds, go calculator. 49 is already in degrees, so there's no conversion there. So 0.5303, 0.5303. And you're going to multiply that by 60 times 60 because you want minutes, right? Equals, and then you have to do it one step at a time. So 31 degrees, right? 49 degrees, 31 minutes, and then subtract that 31.1818 times 60 again. That'll give you, because there's 60 seconds in a minute, 60. And hit compute again, and now you get your 49, 48. Like I said, there's always going to be a little bit of an error between calculator here, this calculator, but if you took it in, put it in Excel, it would be more accurate. But even then, there's going to be a little bit of an error because this is just a random height, right? So this and this have this 117.14. If I went like this and like this, and then went to the dimensions here, and then changed the accuracy, you'll see there's some difference in accuracy here, right? And that's where that little error. But like I said, 1 second. Hundreds is going to be fine. If you just go hundreds for stuff like this, that's your, scribing something out that's for machinery. You would want to go to the thousands for sure. But this is feet. Let's see. So, and then that's how you get the angle, and then how you get the decimal to degrees, minutes, and seconds. If you were in, let's say you're here and you want decimal degrees, because you can't really divide that or multiply it, you would go, let's just draw one up. So 49 degrees, 31 minutes, and 48 seconds. 49 plus and 31 minutes is 31 60ths. So 31 divided by 60. That could give this will also, that's also degrees. 31 60ths of a degree plus, that has to be in degrees too, so it ends up being 48 divided by 3600. Alright, just so you see how it's done. So let's just put that in the calculator. I'm going to go 49 plus 31 divided by 60 plus 48 divided by 3600. 3600, and this knows Control C to do the multiplication first and then do the addition. PEMDAS. Compute. And it's giving me 49.53. 49.53, which is not exactly right, is it? Alt MA. Very close, 49. So it just rounded up that thousandths because that's as far as that calculator goes. But if you went here, Control V equals, it gave it and it's rounding it also to 49. That's a file format number and do it to 4 decimal places. All right. Control C. Oh, that can show you there. Right, there's that formula. And then it's actually still rounding it up, even at 4 decimal places. Control format cells 5. That would be show the 99. Maybe nope. So this is there's just a little bust in there between the actual numbers again. It's just how it's showing up. But that's how you would convert it back to decimal degrees. And what could have been a short video turned into kind of a long video, but I think all these little steps are really important to know. If you don't know them, you'll see a lot of videos, and I think it's true. A lot of these videos will show you one thing, and that's great. It keeps you interested. But if you need to do this for a career, you kind of want to get a broad knowledge, this might help. Hope that helps you in your career, and thanks for watching. Have a great day.